Hello friends, welcome to BMSIT-ISE-Learning YouTube channel. I am Raksha R, currently pursuing Bachelor of Engineering, 6th semester, Department of ISE. As we all know, testing is divided into two types, that is white box testing and the black box testing. In this video, first let us look at the introduction. Next, coming to the data flow testing, that is on the whole, it is a sort of white box testing. And then there are two types in data flow testing, that is define use testing and the slice based testing. This is how the agenda goes. So, coming to the introduction, what exactly is testing? Testing is a process of executing the program with the aim of finding errors, faults, defects, etc. To make our software perform well, it should be error-free. And basically, on the whole, the testing is divided into two types, that is black box testing and the white box testing, as I said before. Now coming to a brief introduction about it, black box testing. Black box testing is a software testing method in which the internal structure is not being tested, and it is usually done by the software testers. As a result, they don't have a very good knowledge of programming. Second is white box testing. White box testing is a software testing method in which the internal structure or the implementation is known to the tester, and this is usually done by the software developers. Here, the software developers must go through each and every line of the code in order to debug the errors. Now coming to our second topic, that is data flow testing. Data flow testing is a form of structural testing that focuses on the points at which the variable receives the values and the point at which these values are used. Let's say, for example, let us consider a simple C program in which in the beginning we would do declarations, right? Saying int a is equal to 10, for example. Here, this focuses on the points where the variable receives the values. So, a will be currently holding the value of 10. And as we go further, say in some line we would have incremented the value of a. The value of a, if we do a++, it will be a is equal to 11. As a result, that focuses on the point at which the values are used. Now let us look at the two mainline forms of data flow testing. That is, one provides a set of basic definitions and a unifying structure of test coverage metrics, while the other is based on a concept known as program slice. As we told before, the first one is define use testing, the second one is slicing. And there are quite a few anomalies with respect to data flow testing. Let us see one by one. The first one is, let us say a variable is defined but it is never used. That is one type of anomaly. The second one is a variable is used but it is never defined. And the third one is a variable that is defined twice before it is used. Before going further, we have to keep a few important topics in our mind. That is, we should learn the definitions of defining node and usage node. Before going to the definition also, we should know a few terms. First one is program. In the following scenarios, we'll consider program and we'll represent it as P, and then we'll consider a program graph represented by G of P and a set of variables, and it is denoted by capital V. The program graph is constructed with the statement fragments as nodes and edges that represent the node sequences. And then let us consider the set of all paths as paths of P. And now coming to the main two definitions, this is very important. First one is a defining node and second one is a usage node. Defining node, for example, let us consider input x and v is equal to 2. As I said before, a place where a variable receives a value is known as a defining node. Say, for example, int a is equal to 10. There we are defining it. So that becomes a defining node. And basically, in a program flow graph, as we have seen before, that is in basis path testing, every statement would be represented as a node. With that in mind, we'll say that int a is equal to 10 will form a defining node. And then coming to the usage node, as I said before, we have incremented the value of a in a simple C program that we had considered before, and currently a holds the value of 11, and there we are not defining it again, instead we are using it, so that becomes a usage node. Coming to the usage node, there are two types of usage node, that is a predicate use node and the computation use node, that is PUs and the CUs. PUs refers to predicate statements, or in a program flow graph, all the statements, or in a program, the statements that corresponds to predicate use forms a predicate use node, that is a PUs node. Usage node, it denoted by PUs if and only if the statement n is a predicate statement. And now the question arises as to what is predicate statement. A predicate statement is a statement in a program that where you have conditions like for loop, while loop, if then else, or if else, so on. And when in a program flow graph, the nodes corresponding to predicate use will always have an out degree greater than or equal to 2. Let us see with an example now. Let us consider a basic commission problem given in our textbook. So in this, the statement, the line number 14 corresponds to predicate use of with respect to logs. And coming to the defining node and usage node example, the log price is equal to 45. This is a point where the variable log price has been assigned a value of 45. So as a result, 7th node corresponding to line number 7, this will be called as a defining node. And line number 24, you're using the value of log price that you had declared before, that is 45, in line number 24. So you're using the value of log price. As a result, this will be called as a usage node. And now a doubt arises for you guys. In line number 10, there should have been total logs and not total barrels. That's a printing mistake. So in line number 10, we are declaring total logs is equal to 0. And in line number 16, you're using total logs is equal to total logs plus logs. That simply means that you are defining it once again and using it. Let us see this with a small example in the form of a tabular column. Yeah, here it is. With respect to that with respect to the basic commission problem given in our textbook, we have constructed this table. In line number 7, as we saw, it is being defined and it is used in line number 24, that is log price. Let us see now. Hope so it's visible. In line number 7, we are defining the value of log price, and in line number 24, you are using the value of log price. Similarly, when it comes to total logs, in line number 10, you have declared or defined total logs is equal to 0. And even in 16, you have defined it, right? This will be considered as defined and used. And in line number 16 itself, you are using the total logs. And in line number 21 also, you are printing logs, so you are using it. And in line number 24, you are using total logs again. So I hope you are all clear with the define use node. Now coming to the two important definitions, that is DU path and the DC path. DU path is also known as definition use path, and the DC path, second one, is also known as definition clear path. A definition path or a DU path is a path in amongst the set of all paths such that for some variable v in set of all variables capital V, there exists a defining node and a usage node such that m and n are the initial and the final nodes of the path. Let us say first node is called m and the last node is known as n. The first node is a defining node and the last node is a usage node, such that m is initial and n is final node, and for m is also known as initial and last one, that is n is also known as final node. Here in case of definition use path, the first node must be the defining node and the last node of consideration must be a usage node. In between you can have any number of nodes, provided it won't matter whether it's a defining node or a usage node. For now, understand this, and in few minutes we'll see with an example. Coming to the second definition, that is a definition clear path. A definition clear path or a DC path is a path among the set of all paths, that is paths of P, with the initial node we'll call it as m and the last node, final node, we'll call it as n. That must be a usage node such that no other node is a defining node. in case of definition use path, the first one was a defining node, last node of consideration was a usage node. In between there could have been any number of nodes, and it didn't matter whether it was a defining node or a usage node. When it comes to definition clear path, the first node is a defining node, the last node is a usage node. In between you can have any number of nodes provided it is not a defining node. Hope so the definition is clear, and now we'll see with an example. Let us consider DU paths for stocks. Here we have first node is a defining node, that is in line number 15 we are taking input with respect to stocks, and in line number 17 we are using stocks. So this 15 will be a defining node and 17 will be a usage node, and that path is known as a DU path because the first must be defining and last must be usage node for a DU path. In between you can have any number of nodes, it can be either usage node or a defining node. So here in line number 15 you are taking as input, and that will be a defining node, and line number 17 that will be a usage node. And since there are no defining nodes in between, that is also definition clear. So a definition clear path is always a DU path. I repeat, DC path is always a DU path, whereas DU path is not always DC path. Remember this. And then coming to the second example, DU paths for logs. Let us consider the two usage nodes and the two defining nodes. The first one would be definition node, that is in line number 13 you're taking input log input, and in line number 14 you're using it, isn't it? While not, I told before, while not logs is equal to -1, this is, you have a condition statement here, so it will be a predicate use. Okay, however we are using it, right? So that will be a usage node. So with respect to logs we are using it, so that will be your usage node. And in line number 16 we are using it again, so that will be your usage node again. And in line number 19 also we are using logs, so that will be our defining node. You are taking input there. And then let us consider a path for a DU path or a DC path. The basic condition is that the first must be a defining node, last must be a usage node. So why can't be there a path from 13 to 14? In 13 you are taking input, right? That is your defining node, and in 14 you are using it, that is a predicate use statement. However, it's a usage node, right? So there can be a path from 13 to 14, and that will be your DU path. And you can also consider a path that is 13, 14, 15, 16. In 13 you're using, and in 13 you're defining it, in 16 you're using, and the path between 13, 14, 15, 16, that will be your DU path. And since you're using it, yeah, this will be your DU path. In P3, why can't be there a path from 19, 20 and 14? 19 you're defining it, 20 is the end of while loop. Once the while loop ends it must go back, and 14 you're using it again, so that can also be a path. And P4, that is 19, 20, 14, 15, 16. 19 you're defining, 20 is the end of while loop, and 14 the control comes here again, so 14 you're using it, 15, and then 16 is finally you're using. So even that will form a DU path. Now for more clarity, let us look another example of DU path and DC path, that is for the variable total logs. In this, as it is shown here, let us take two examples, one for definition clear and the other one for DU path. We have already seen DU path, but for more clarity we'll see another example. For total logs there can be so many nodes, that is defining nodes and usage nodes. In case of defining nodes, as I said before, it will take the variable total logs will be assigned a value, and in case of usage node that will be a node that corresponds to a statement in the program where the value of variable will be used. So let us take P6 for example. Let us say there exists a path from node number 10 to node number 21. So according to our definition that we saw before, 10th must be a defining node and 21 must be a usage node in P6 path. So let us consider path that is from 10 to 21. So in line number 10 we are using total logs. As I said before, this should have been total logs and not total barrels. So line number 10 corresponds to total logs. You're defining there. Line number 11, 12, you'll just traverse, that's your path, and it doesn't mean anything else. And in line number 13 you're taking input for logs, and 14 you're using logs, that will be a usage node, and 15, 16, 17, 15, 16, 17, 18, 19, 20, and 21, 22, 23, 24. In 24 you're using, in line number 10 we define total logs, and in line number 24 you're using total logs again. So this path will be a definition use path, but since in between we have redefined it, this cannot be a definition clear. See, as they have given here, we have a DU path and that fails to be definition clear just because in line number 16 we are defining total logs again. And now let us see an example for definition clear, that is path 8, 16, 17, 18, 19, 20, 14 and 21. In line number 16 you are defining it. So that will be your initial node, that is M, also known as defining node. In line number 17 you have some other statement, and that's nowhere related to total logs or logs. And in line number 18, line number 19 you're using logs, but we are concentrating on total logs. And then line number 20 is the end of while loop, and the control comes here, that is beginning of the while loop. And in line number 14 you're using it. Line number 21 you're printing total logs and you are using it, right, anyways. So in between in the path from 16 to 21 there is nowhere you are redefining it again. So this is successful, and this can be a definition clear example. Now let us look at program slicing, that is the second part of data flow testing. Program slice is basically a set of program statements that contribute to or affects the value of a variable at some point in a program. We continue with the notation we use for DU paths. A program P, that is program will be denoted by P, program graph will be denoted by G of P, and set of variables used in the program will be used by capital V. And now coming to the definition, given a program and a corresponding program flow graph in which the statements and the statement fragments are numbered, and a set of variables in P, the static backward slice on the variable at the statement fragment N is represented by S, V, N. S is a slice, and then V is a variable that we are considering, and N is a line number. It is a set of node numbers of all the statement fragments that contribute to the value of variable V at statement fragment N. And in slicing, basically we'll have two types, that is a backward slice and a forward slice. Let us see with an example now. In this program, in line number 10 they have defined total logs is equal to 0, and here we are defining it again, saying that total logs is equal to total logs plus logs. All the statements before 16 for the variable total logs can be called as backward slice, and the statement following the line number 16 and wherein all the new updated value of the total logs is used can be called as a forward slice. Slicing is basically dividing a program into set of statements so that it can be easy. It's easy for the calculations. Then coming to the forward slice and backward slice, what we saw now. Backward slice refer to statement fragments that contribute to the value of V at statement N, and forward slice refer to all the program statement that follows the statement. Let us see with an example now. For the simple commission problem, we have considered too many slices, that is 42 number of slices, and as I said before, S is a slice, and then goes the variable name, and the second parameter would be the line number. So in line number 7, this simply means that in line number 7 log price have been defined, and the first 7 slices are too simple, where we have just declared it or defined. In line number 1, that is in slice number 1 that corresponds to line number 7, we have defined log price. Similarly goes 8, 9, 10, 11, 12 and 13. So till 13 we have just defined all the values. In 13 actually you're taking the input, till 12 you have defined, and in 14 you're using it, so even that will be a slice. And in line number 15, that is slice number 9, you're taking input as stocks, and after that you're taking input as barrel, so that must go in 2 separate lines and not in a single line. And then goes in slice number 11, that is line number 16, we have total logs is equal to total logs plus logs. So first you have to concentrate on this logs part. So first you'll write S11 is equal to S of logs, that is the last part what we have already defined here. We have taken logs as input, so we have already defined it. You have to concentrate on this, and then goes the total logs that we have already defined before, and now since you're redefining it, you should write it once again. So for this line number 16, while writing slices, you will have 2 slices for line number 16. Similarly 17, we know stocks, so that will be one slice, and total stocks, that will be another slice. Similarly, if you want to see for commission, in line number 32, line number 31 is a line where you are using commission for the first time in the entire program. So line number 31 corresponds to slice number 37, and after that you have 32, 33. In 33 you are also using slice, so line number 33 must also be included. Whatever we know before, even that will be a slice. And 36, 37 also you have, and then at the end 39. And outputting this part, it's not necessary. As I said before, the first 7 slices are too simple. First 6 slices are too simple. They are just defining. And when it comes to slice number 7 through 17, let us see here. Slice number 7 through 17 focuses on the sentinel control loop. Let's say, for example, S7 logs. That simply means that they have concentrated only on this while loop and not anything else. So S7, that corresponds to line number 13. You're taking input for logs, so you've just written S of logs comma 13, and in the path you're writing only 13 because it's not passing through any other node. And then in slice number 8, you have taken logs in line number 14. So 13 you have taken input for stocks, and then 14 is a while loop, and then 15 you are actually taking stocks input, and then once you enter a loop you also have to come out of it. So 19 and 20 you are considering as a path. Similarly, if you want to consider slice number 12, that is total logs comma 16, we'll concentrate on 16. You can't directly jump to this. You have to come from you have to enter the for loop before that. So taking 13. In line number 10, they have taken total logs, right? In total logs they have defined it to be 0, so let's take 10. And then 13, 14, 15 is basically stocks. It has got nothing to do with logs basically, so you're not taking 15. Then 17, 18 is also not required, and then 19 and 20. 19 is the end of the you're taking input logs to check whether the loop continues, and 20 is the end of the while loop. So let us see with an example now. For the simple commission problem, we have considered too many slices, that is 42 number of slices, and as I said before, S is a slice, and then goes the variable name, and the second parameter would be the line number. So in line number 7, this simply means that in line number 7 log price have been defined, and the first 7 slices are too simple, where we have just declared it or defined. In line number 1, that is in slice number 1 that corresponds to line number 7, we have defined log price. Similarly goes 8, 9, 10, 11, 12 and 13. So till 13 we have just defined all the values. In 13 actually you're taking the input, till 12 you have defined, and in 14 you're using it, so even that will be a slice. And in line number 15, that is slice number 9, you're taking input as stocks, and after that you're taking input as barrel, so that must go in two separate lines and not in a single line. And then goes in slice number 11, that is line number 16, we have total logs is equal to total logs plus logs. So first you have to concentrate on this logs part. So first you will write S11 is equal to S of logs, that is the last part what we have already defined here. We have taken logs as input, so we have already defined it. You have to concentrate on this, and then goes the total logs that we have already defined before, and now since you are redefining it, you should write it once again. So for this line number 16, while writing slices, you will have two slices for line number 16. Similarly 17, we know stocks, so that will be one slice, and total stocks, that will be another slice. Similarly, if you want to see for commission, in line number 32, line number 31 is a line where you are using commission for the first time in the entire program. So line number 31 corresponds to slice number 37, and after that you have 32, 33. In 33 you are also using slice, so line number 33 must also be included. Whatever we know before, even that will be a slice. And 36, 37 also you have, and then at the end 39. And outputting this part, it's not necessary. As I said before, the first 7 slices are too simple. First 6 slices are too simple. They are just defining. And when it comes to slice number 7 through 17, let us see here. Slice number 7 through 17 focuses on the sentinel control loop. Let's say for example S7 logs, that simply means that they have concentrated only on this while loop and not anything else. So S7, that corresponds to line number 13, you're taking input for logs, so you've just written S of logs comma 13, and in the path you're writing only 13 because it's not passing through any other node. And then in slice number 8 you have taken logs in line number 14, so 13 you have taken input for stocks, and then 14 is a while loop, and then 15 you are actually taking stocks input, and then once you enter a loop you also have to come out of it. So 19 and 20 you are considering as a path. Similarly, if you want to consider slice number 12, that is total logs comma 16, we'll concentrate on 16. You can't directly jump to this. You have to come from you have to enter the for loop before that. So taking 13. In line number 10, they have taken total logs, right? In total logs they have defined it to be 0, so let's take 10, and then 13, 14, 15 is basically stocks. It has got nothing to do with logs basically, so you're not taking 15. Then 17, 18 is also not required, and then 19 and 20. 19 is the end of the you're taking input logs to check whether the loop continues, and 20 is the end of the while loop. So slice number 18, 19, 20 are the output statements. In slice number 18, that corresponds to line number 21, you're outputting total logs. Similarly in slice number 19 and 20, you're outputting total stocks and total barrels respectively. In slice number 21 to 30, we are calculating the variable sales. If you take line number 24, that corresponds to slice number 21, you are using log price. Log price we have already defined in line number 7, so you're taking that also, and then that is required. And then in the slice number 22, that corresponds to line number 24, again you're using total logs, and total logs we have already defined in line number 10. So from 10 10, and we need to enter the while loop for this. So 10, 13, 14, and then you have 16, because your this is where actually you're calculating total logs. And after that we have in end of the while loop, and then you're taking input for logs. So this is how total logs goes. Similarly, you can write the paths for all these variables given. If you say line number 30, that is sales, that corresponds to line number 27, you have to take slices for total log sales, stock sales, and barrel sales. So you can't directly jump to calculate log sales. We need to know, we have to come from line number 7. We need log price, stock price, barrel price, total logs, total stocks, and total barrels. So all these nodes have been included: 7, 8, 9, 10, 11, and 12. And 13, because this is where actually you're calculating total logs, total stocks, and total barrels, so you have to enter the while loop. So before that you have to take input for logs, so 13 has been included. 14, 15, 16, 17, 18, 19, 20 is where actually you're calculating the total logs, total stocks, and total barrels. And after that you're not considering the 3 output statements, that 21, 22, and 23, and then directly we're jumping to calculate log sales, stock sales, and barrel sales, and finally using all these parameters you're calculating sales. Hope so till here it's clear for all of you. And then coming to slice number 31 to 36 are identical, basically 31 to 36. So you don't have much here, because if sales exceeds 1800, then all these 3 statements will get executed, else these two statements will get executed. And the last 7 slices deals with the calculation of commission of the values of sales. So in line number 31 we have these 3 parts where sales is greater than 1800, sales is greater than 1000, and sales and the else part, all these 3 parts is basically included in the last 7 slices. So in slice number 37, that corresponds to line number 31, till sales we have traversed already, right? And then from there onwards you have to also traverse 25th till 27. We have already traversed before, that is for sales, because in order to calculate commission you also need sales, so even sales part is required for it. Plus, in addition to that, line number 29, if this condition is important, if sales is greater than 1800, then control comes here, then 31 and 30 and 31 will get 31, 32, and 33 must get executed. And then if commission of sales, only 31 is getting executed for the first time, and then it says following it you have 32 and 33 also, if you observe. That is, that corresponds to line number 32 and line number 33. All these 3 statements will get executed. Similar is the case with when the sales is greater than 1000, we'll include the sales part, and after that if you're considering till line number 36, at the end you'll have only 36, and if you are slice, the end part of your slice is line number 37, then you'll include line number 37 also. Now let us see how to construct a full lattice and commission. With respect to the previous topics what we had discussed, line number this basically uses a top-down approach. So slice number 43 is just an imaginary slice or a node, you can say. And then slice number 43 is the ultimate aim. The ultimate aim of all this is to calculate commission. So to calculate commission, you have to go through line number slice 39, slice 38, and 37. If that is the case when the sales is greater than 1800, all these 3 slices will get executed. If sales is greater than 1000, these 2 slices will get executed. And if that is not the case, if that is the else case, then slice number 42, that corresponds to line number 39, will get executed. And in slice number 30 is where we are calculating the sales, overall sales. And in order to calculate all these things, we need sales, right? So we have included that. We are using top-down approach for this. I repeat, in this slice number 37, you're calculating commission rate 37, 38, 39, 40, 41, 42, and 43. So in 43, it's a union of 39, 41, and 42. And in case of 42, it's 30 and the paths 29, 34, 38, and 39. See, it's very well depicted here. In slice number 42, all this will be included. In slice number 41, we are concentrating on these two statements that correspond to line number 36 and 37, and in case of slice 39, 38, and 37, we are using 31, 32, and 33 line numbers, and in slice number 30, we are calculating the total ultimates. In order to calculate sales, we need log sales, stock sales, and barrel sales. So we are using slice number 23, slice number 26 that corresponds to stock sales, and slice number 21 that corresponds to barrel sales. See, so it's given slice number 23, 26, and 29. In order to calculate slice number 23, that is the log sales, we need slice number 21 and slice number 1. So let us see, slice number 21 and slice number 1, you need log price for that, and slice number 1 is also a log price. So in the program, slice number 21 that corresponds to 24 line number, and you're in 24 you're calculating log price into total logs. Log price we have already seen before in slice number 1, and in slice number 21 we are using log price, and then in order to calculate log sales, we also need total logs. So they have included, it's been shown like this. We are done with the log price part now. In slice number 22, we are actually defining total logs. In slice number 22, we are defining total logs. So we are done with this statement now. Calculating log sales is equal to log price into total logs. And now a doubt arises as to what this bidirectional arrow indicates. Bidirectional arrow indicates that the contents of both these nodes are same. Say for example, slice number 21 you are calculating log price, and in slice number 1 you are defining log price. So in between the value is not changed, and the same value, that is 45, is being carried throughout the program. So we use a bidirectional arrow here. And then similarly, this is the case for calculating the total log sales, and this is for stock sales and the barrel sales. And at the end, you calculate in slice number 8 and slice number 7, you are entering the while loop. Since this is a top-down approach, first your aim is to calculate the commission, then goes the sales, and then in order to calculate sales, we need total log sales, stock sales, and the barrel sales. And in slice number 8 and slice number 7, let's see. In slice number 8, you are inputting the logs. In slice number 7, you are entering the while loop. So first you are inputting and then you are entering the while loop. That is the basic condition to calculate the commission. So it has been included at the bottom. And all this have been given in the form of paths. That is, you can say for example, I say it logs 14, it can also be written as, you can take the output of this slice 7, you can union it with the paths 14, 19, 20. Now coming to the last topic, that is, in VTU syllabus, the program number 9 is based on Dataflow testing, and for that we use commission problem. The statement of the problem is as follows: design, develop code and run the program in any suitable language to solve the commission problem, analyze it from the perspective of Dataflow testing, derive different test cases, execute these test cases, and discuss the results. So the problem definition: the commission problem includes a salesperson in the former Arizona territory sold rifle, lock, stocks and barrels made by a gunsmith in Missouri, and cost includes the cost of the locks, stocks and barrels are $45, $30 and $25 respectively. The problem is such that a salesperson has to sell at least one complete rifle, that is one lock, one stocks and barrels in a month, and based on and production limits were such that at most the person can sell only 70 locks, 80 stocks and 90 barrels, and then he'll be given commission based on his sales. So if the total sales is within 1,000, then he'll get 10% commission, and if it is up to 1,800, if it is greater than 1,000, less than 1,800, he'll be given 15% commission, and if it is greater than 1,800, he'll be given 20% commission. The statement of the program is as follows. And then now coming to the algorithm, first we'll declare lock price, stocks price and barrel price as 40, 30 and 25, and then we'll take a user input. We'll ask the user to input value for locks, and then we'll run a while loop, and within while loop we'll input stocks and barrels, how we saw in the commission program, and then we'll compute total lock sales, stock sales and barrel sales, and using all the three parameters we'll end up calculating the ultimate sales, and we'll print the sales, and then comes a calculation of commission, that is if the sales is greater than 1,800, we'll execute these three lines. Commission is equal to 10% of 1,000, and commission is equal to commission plus 15% of the remaining 800, and commission is equal to commission plus 20% of the overall sales minus 800. If that is not the case, if the case is such that sales is greater than 1,000 but if it is less than 1,800, then these two lines will get executed. The commission is equal to 10% of the 1,000, and the commission is equal to commission plus 15% of the remaining sales minus 10,000. If that is not the case, that is a basic case, if the commission is less than 1,000, he'll be given a commission of, if the sales is less than 1,000, he'll be given a commission of 10%. Now let us see the implementation of the commission problem using the C language. In the beginning we have used #include stdio.h and #include conio.h, and then inside the main function we'll declare lock, stocks, barrels, and t sales is the total sales, and we'll make flag is equal to 0, and later on we'll give float is equal to commission. For float we'll declare commission with respect to float, and then we'll ask the user to enter the number of locks, and then if locks is less than 0, or if locks is greater than 70, that is invalid case, we'll make flag is equal to 1. And then in line number 14 we'll ask the user to enter the stocks, and if stocks is lesser than or equal to 0, or if it is greater than 80, we'll make again it's an invalid case, and we'll make flag is equal to 1. And then in line number 20 we'll ask the user to enter the number of barrels. If barrels is less than or equal to 0 and barrels greater than 90, we'll make flag is equal to 1. If finally we'll say that if flag is equal to 1, that is an invalid case, or we'll print saying that it's an invalid input, and we'll exit from the entire program. If that is not the case, if the user has entered all the valid values for locks, stocks and barrels, then control goes to line number 32, and he'll calculate total sales as locks into 45. 45 is a lock price, if you remember. Lock price, that is a cost of one lock is 45, and stock is cost of one stock is 30, then barrels is 25. And then in line number 33, once you've got the total sales, in order to calculate commission, we have three cases. We need to compare the total sales with the 1,800, and if it is greater than 1,800. So let's see the first case now. If total sales is less than or equal to 1,000, that salesperson will be given a commission of 10%. So it will be 10% of total sales. Else if the case is total sales is less than 1,800, then you'll have two statements. The two statements will be executed, that is the commission will be 10% of 1000, and the other would be commission is equal to 15% of the remaining amount. And then if that is not, if those two is not satisfied, then obviously the last three statements will get executed. That is, commission will be calculated as follows: commission will be 10% of 1000, commission will be 15% of the remaining 800, and commission is equal to 20% of the total sales minus 1800. And at line number 48 you will print the total sales and commission. Now let us analyze how much we know about data flow testing. So with respect to, once you have written the program, the second step would be construction of the table, in which you list the occurrences and assign a category to each variable. So with respect to program, so as I said before, the program should be line numbered, and once it is line numbered, you have this, you have a column saying definition and then CUs or PUs. You will just list them. In line number 5 you have defined, in line number 5 we have defined flag. Let us see here. In line number 5 we have made flag is equal to 0, so it's written under definition. And if you see in line number 9 we have taken input for logs. So in this you are defining value of logs, that is variable logs will be assigned some value, that is during the runtime user will be asked to enter the value of logs, and that will be called as defining, or you defining node. So under you will write logs under definition, that is you will write only the variables that you have defined. And in line number 10 we are using logs. You can see in line number 10, if logs is less than or equal to 0, since it is in the if statement, it comes under predicate use, so you are mentioning it under PUs. And in line number 12 again you are using it as a CUs. In line number 12 you are redefining it, or you are using the value of flag, you are modifying it to 1, so in line number 12 you will write it as CUs. Similarly you can go through all other variables. In line number 32 if you take, we have total sales is equal total sales mentioned under definition. In line number 32 we have total sales mentioned under definition, because in line number 32 you are calculating all this and assigning the output of all these calculation to total sales. So you are defining it here, and you are also using logs, stocks and barrels, and it is a CU since it is not included in any conditional loops. It is called as CUs. That's it. And when you come to commission, in line number 35, you are defining commission is equal to 10% of total sales, so it's been included under definition, and you are using T sales for it. And if you see in line number 39 and 40, let's say in line number 39 and 40 it's being defined again and again, and in the line number 40 you are using T sales. So this is what is depicted here. In line number 39 and 40 you are using commission, in line number 40 you are using commission as well as T sales. So this is how you'll list the occurrences and assign a category to each of the variable. Now let us see how the second table is constructed. The second table just gives us whether it is a DU path or DC path, and then variable CUs and PUs respectively. So if we consider a path from line number 9 to 10, we are using P logs. In line number 9 we are defining logs, that is a defining node, and in line number 10 we are using it since it is enclosed in a if loop, it is a PUs. So line number 9 to 10 gives us a PUs with respect to variable logs. Similarly in 15 to 16 stocks, 15 is defining node, 16 is a usage node, and then 21 to 22 also is with respect to barrels, that is defining node, and the predicate usage of barrels. Now let us see an example with respect to flag, that is 5 to 25. In line number 5 we are defining flag is equal to 0, and till in 25 you are defining it again, that is you are using it, not defining, you're using it. So it will, from line number 5 to 25 it becomes a DU path. In between you can use it, but in between you are not defining it, right? In case of DU path you can use as well as define. For it to be a DC path it should not be defined in between. So this forms a DU path from line number 5 to 25. So you have included it under a CUs, that is flag. And then if you see T sales from 32 to 40, from 32 you're defining T sales, and in 40 you're using it so even 32 to 40 forms a DU path, that is T sales. T sales is being used as a computation use. That is how this table is being constructed. We'll list for all the values, like for commissions, barrels, logs, stocks and all. And third table is the ultimate table that gives us the DU pair, subpath, log, stocks, barrels and total sales and commission. This is where we'll calculate commissions. If we consider a path from line number 9 to 20, line number 9 to 20 forms a DU path. In line number 9 you're defining logs, and line number 20 you're using you're taking the value of barrels. And then the subpath will be 9, 20, 9, 10 and 20, because in line number 9 you are defining it, in line number 10 you are using it, in line number 20 you are asking the user to input the barrels. And the logs, in that path from 9 to 20 you will take the value of logs as 10, stocks as 10 and barrels as 10, and thus you will end up getting total sales is equal to 1000, but then you will not calculate commission. In case of logs, stocks and barrels, if you consider a path from 9 to 10, if you take logs, stocks and barrels as a variable, and if you consider a path from 9 to 10, that is, you are in line number 9 you are just defining logs, and in line number 10 you are just using logs, and the path is from 9, 10, and then logs in the range from 9 to 10 you can give value only for logs, because you wouldn't have traversed to the lines where you take the input for stocks and barrels. So the input would be negative, and then you end up getting invalid input. And if you consider T sales 32 to 33, so now in order to calculate T sales, all these values must be evaluated, logs, stocks and barrels. So we have taken this as input. 32 to 33 let us consider, because in 32 you are defining T sales and 33 you are using it. And for T sales, to calculate T sales you have to take a valid value for logs, stocks and barrels, and if you take 5 for all the 3 variables, you will end up getting total sales is 500. So in 32 to 33, in 32 you are defining, in 33 you are using it, so that can be a DU path, and you will get valid answer for this. And then if you calculate commission, let us say from line number 39 to 48. In line number 39 you are defining commission, you are defining a line number 39 to 48. 48 is where you are using it, and that will be a computation use. So 39 to 48 will be a DU path. In 39 you are defining it, and then you are using it. Okay. So there will be a path from 39, 40, 44, and then the doubt may arise saying that how do we write the subpath? That simply means that in line number 39 to 48, in line number 39, 40, 44, 45, 46, 48, there is commission mentioned in that. Let us see 39, 40, 44, 39, 40, 44, 45, 46, 47. and in 48. So in all the lines in which commission has been mentioned, or there is a role for commission, then those statements, those line numbers can be included under subpath. And then since to calculate commission, you need a valid value for lock stocks and barrels. If you take 15 each, you'll end up getting 1500 as T sales, and you'll get a correct output for commission. Thank you for watching this video. Please do like, share and subscribe if you haven't done it. You can drop your queries in the comment section. Stay tuned for further videos. Spread the light of knowledge. Thank you.